That was really great, Ben. Thank you. And I apologize that the second half of the Vietnamese comedy hour won't be quite as funny as the first, but there's no way to match that. So it's such a pleasure to be here. I also apologize. You might hear me coughing every once in a while. Since Ben has started us off sharing bodily functions and things, I had a cold 3 weeks ago. It wasn't COVID, it was just a cold. But I have this thing where if I get over a cold, I still cough for like 6 weeks. So if you hear me cough, you're standing next to me or something, you're not going to get disease from me. So just to let you know that. But it is such a pleasure to be here. And thank you so much for giving me this opportunity to talk a little bit about the impact of AI on clinicians, researchers, and society, benefits and pitfalls. Let me move this along. I just want to, in all seriousness, take a moment to thank really these 4 folks at ANZUP for helping to build my career. So, today, I'm a professor at Harvard. I just took over the leadership of the NRG-GU Cancer Committee. But 12 years ago, when I was just a young assistant professor, it was Ian Davis and Martin Stockler and Chris Sweeney and Scott Williams who welcomed me here, took me under their wing, and allowed me to have leadership of the NZRAD trial, or co-leadership of the trial, which was an incredible opportunity for me and really launched my career. And I really appreciate that. And it's such an honor and a pleasure for me to finally be here with them and with you. So I do want to thank you for that. All right. And also, many thanks to the Women in Brigham's or Brigham Women, whatever, Dana-Farber AI experts for their slides. So my qualification for being here and talking is that I work in close proximity to real AI experts, Ray Mack, who's a lung expert, and Danielle Bitterman, who's also in the lung group, and they are these real AI pioneers. So when you think about Brigham Women's, Dana-Farber, Harvard AI people, you think about Ray, you think about Danielle, you don't think about this guy. So, basically, you all know about the Chicago Bulls, right? The big champions of the 1990s. You got Michael Jordan, Scottie Pippen, and you guys asked the Chicago Bulls to send, some basketball representative, and you got this guy. Everybody loves InXS. You wanted to see Michael Hutchins. You got this guy. Sorry. That's what you get for dinner entertainment. So what is artificial intelligence? And I appreciate, again, Ray and Danny shared a lot of their slides with me. But artificial intelligence, back in the 50s, this was computer systems performing tasks that normally require human intelligence. And then we got to machine learning, which is when the techniques allow the computers to start actually learning and improving their performance without us overprogramming them. Then you get deep learning. This is these matrices, these networks that have many, many layers and can process large amounts of data. And then finally, we've reached now generative AI, ChatGPT, where you can actually create new knowledge and new content. And if the question is, is AI good or bad? I think all of us we have to face the elephant in the room. We are pretty pissed off right now at the CrowdStrike Falcon, which is touted as the world's only AI native platform. And based on that, it basically put us back into the dark ages. The article to the right is my own hospital, Brigham and Women's, where the global software outage basically shut off all surgeries, all elective procedures, and canceled all the radiation on Friday. Not a single patient got treated, and this is because of this AI-enabled antivirus technology. All right, let's talk about certain aspects of AI. So this is a thing that is very familiar to us. This is AI figuring out how to discriminate images. And this is based on convolutional neural networks, which I learned all of this from the University of YouTube. But basically, AI, this kind of convolutional neural network is very good at discriminating one thing from another. And basically, you've got these multiple layers. A convolutional layer is basically a filter that is trying to discriminate different parts of that image. And then you've got these pooling layers that kind of boil it down to something more simple. And then that fully connected layer on the right that actually puts all this together and makes a judgment. Is this a horse or is this a zebra? And it can tell one from another. And so AI's gotten really good at that. Generative AI, the way this came about, is, if you're going to actually create new knowledge, you have to have new techniques to do this. And this thing came out about 10 years ago, these generative adversarial networks. And this is really cool. Basically, what it tries to do is if you want AI to make a new image and to make a fake image, you have it compete against another competing AI that's there to detect a fake image. So these two are competing against each other. One is trying to make a really good fake to fool the other one, which is trying to detect a fake. And at the beginning, the one that is detecting the fake is winning every time. It's crushing the one that's trying to make the fake. But eventually, the one that's trying to make the fake actually learns how to make a good fake and actually fools its competitor. And that's how AI is able to basically generate new images and new knowledge. And these are the things that we're dealing with today. There's large language models, so text-based AI. So if you ask ChatGPT, please describe an Australian oncologist specializing in genitourinary cancers, you get this nice thing, and then you get this thing about their demeanor and interactions. They would project a calm and confident demeanor, vital and reassuring patients facing serious diagnoses. They have empathy, understanding the emotional impact of cancer. They would demonstrate empathy and compassion in their interactions. That's pretty good. That's pretty good. And then you have natural language processing. This extracts information from language into features that computers can analyze for downstream tasks. So you take all this text and then you turn it into actually hard-coded things that computers can analyze. There are many disruptive forces out there. So there's a vision for the future that clerical workers will be replaced by natural language processing. Transportation will just be replaced by self-driving cars. Arts and entertainment, you don't need artists anymore. You don't need painters, musicians. This can be replaced by generative AI. And same thing in radiation oncology. Maybe all of this stuff can be automated. But there actually are many areas of radiation oncology that could be helped by AI. Treatment decision-making, imaging could be better. Treatment planning could be faster. QA could be better. Even the delivery could be better, and follow-up care. So this is an example of radiomics, and you can actually draw an analogy to the self-driving cars. So you use these same convolutional neural networks for classification and segmentation. This can be applied to CT scans. And using AI, you can tell things from CT scans that the human eye cannot see. You can use this deep learning model, which my colleague Ray Mack did at Dana-Farber Brigham, to look at a whole bunch of CT scans for patients with lung cancer and try to use AI to take the images and classify their likely outcomes and response to treatment, and was able to find that whether a patient gets radiation or surgery, just the imaging, these imaging characteristics that you can see from the CT scan can differentiate patients' outcomes. You can also transform follow-up care. So these are recurrent neural networks, which, as YouTube University explains, is looking at sequences over time. And so in the same way that it can predict how cars are going to move when you have a self-driving car or other objects are going to move, it can predict how a patient's tumor is going to respond based on a few follow-up scans. So if you see after a few follow-up scans that this tumor is responding well, maybe you don't have to follow that patient up for a long time. And that has been proving to be pretty interesting. These are two residents that graduated from our program, and they looked into cardiac health and biological age. So one, Dr. Katie Atkins, was able to use the images from a CAT scan to predict the risk of a heart attack, so looking at calcium as a predictor. And the other one, Dr. Subrapurni, was able to look at lung age. So how old are you based on your chest x-ray? Do you have the lungs of a 60-year-old or the lungs of a 75-year-old? And I want to show you something really cool that Ray did in our department. He built something called face age. Face age is a really cool idea, and it's basically that you can tell a lot about a patient and their health from how their face looks. So what they did was they went to the internet, and they went to IMDb and looked at celebrities and looked at their faces and their known ages at the time, and basically was able to train a model to figure out how old somebody is based on their face. And then they applied this then to a population of patients who were getting radiation in our department. And you can now detect the face age of a patient. So this patient on the left has a chronological age of 60, but their face age is much younger. So the face age predicted them of being only 50 years old. So you get the idea. And what they found basically was that patients with cancer look older than healthy individuals. So the face age is actually a very good predictor of the age of a healthy individual. But when you look at a patient with cancer, their face age tends to be about 5 years older. And the face age predicts overall survival in cancer patients. So this is a pretty amazing prognostic tool now. It provides information beyond the standard clinical features, and it improves end-of-life prediction. So if you give somebody a picture of a patient, and then you give some clinical characteristics, the doctor can make a prediction, and the face age is actually better than that prediction. So it's pretty cool in terms of how AI can augment clinical decision-making. This is an example from radiation oncology. This is looking at tumor auto-contouring for lung cancer. So you can train a machine on how to do contouring. Most of what we do and what we get paid for is contouring. But a machine can do this now. And the AI can contour in seconds the tumor. And this is 8 different reasonably expert radiation oncologists contouring, different ways. So that's a little bit concerning. And having the AI contour for you makes you 65% faster. Of course, you have to edit things, but you're going to be a lot faster with it. You feel a lot more confident in terms of time savings, and it feels less challenging to you. So about the things that Ben was talking about, it improves your quality of life if you have AI to help you contour. But here are some warnings. I'm not just supposed to rah-rah about AI, but I'm also supposed to talk about what are some of the things that we should be worried about. And this is worrisome. Sometimes AI gets it totally wrong. I mean, AI is not perfect yet. AI can make mistakes. And these are examples where what the correct human contour is what's in red, but what AI contoured was what's in blue, which is really tiny. So there are circumstances where AI is dealing with something that it's not used to. It wasn't really trained well on. It's not performing well on this. And it could totally screw things up and really harm the patient if we just accept whatever the AI is doing. This is sort of the example, which I'll come to again, but you probably all heard about the Tesla car that is doing, auto driving, and there was a guy that basically fell asleep at the wheel, let the Tesla do the driving on a highway, and then a truck cut across the highway, and the Tesla didn't recognize it as a truck cutting across the highway because it's not trained in that, and drove right under the truck, and the person was killed. So it's that kind of thing where AI is really good on what it's trained at, but when it's in these unusual circumstances, it can be really dangerous. And our patients have those unusual circumstances. So that's something we really do have to worry about. Natural language processing, this is something that Dr. Danielle Bitterman has done a lot on. And basically, it's taking text that we type, a random note, and turning it into data that a computer can actually use, hard-coded data that's classified and that you can do things with. And the thing that's built beyond that is these large language models. So large language models is trained on a huge amount of data. So it's trained on all of Wikipedia, the entire New York Times, all of PubMed. So it learns all of this, and it's able to do tasks because of all this knowledge that are very complex. It doesn't have to be trained for a specific task. It just has so much generalized knowledge, it can do a lot of things. So these large language models can actually pass the USMLE exams. They can answer complex health information questions. They can summarize clinical reports into plain text and make diagnoses better than lay people. And this is an example of how Dr. Bitterman tested large language models for clinicians. So they used ChatGPT to determine whether ChatGPT could respond to your patient's questions. All of your patient email questions that come up in Epic, they had ChatGPT write an AI-assisted answer, basically, or an AI answer. And what did people find? People liked having the AI answer. The doctors found that with the AI answer, it improved their efficiency. They could give more information in less time. But here's the worrisome thing. I really want to point your eyes to the thing on the right, that 8% of unedited ChatGPTs could cause serious harm or death. So if you just start to accept this and just hit send to the patient, 8% of the time you could be killing your patient with AI. So I think it sends home the message that AI is good, it can help us, but it's not quite there yet. It's not perfect, and it really does require, for patients, human intervention and human oversight. Same thing, this is looking at patient education. So if you want to give information to a patient about their diagnosis, 98% of responses had some NCCN guideline information, 34% had information that was not in agreement with NCCN, and 12% was just straight up hallucinated information, like stuff that the AI just made up and just made absolutely no sense at all. So these are worrisome things, and I think it gets to this model. So if you just pay attention to the curves there, back in the early days of AI, humans were crushing AI. Humans were outperforming AI by far. And now AI is is getting better at humans on certain very specific tasks, but we're not at the place yet where AI is markedly better than humans and doesn't require human intervention at all. So we're still at that stage. This is another application, which is clinical trial matching. We all know how hard it is to get patients on clinical trials. AI can help us do that. It's not quite there yet. It still needs to be trained further. I do want to talk for a moment about, or hone in on the pitfalls. One of the big pitfalls is bias. So many of these AI models are trained on information that includes our biases and has bias. So if you have biased data that comes in, biased models will come out. We already talked about human over-reliance on AI, and despite conflicting data, there's concerns about the quality of data, and then lack of access to technology that could worsen health inequities. I know we're going to talk about health inequities tomorrow. And then as Ben talked about, the human side of the patient-doctor relationship. By the way, I asked ChatGPT if they could just do this talk for me and talk about all the potential pitfalls, and actually they did really well. They came up with data quality and bias, interpretability, privacy, integration with clinical workflows, liability. Who's liable if AI makes a mistake? Are you liable? Ethical considerations, validation. Who's gonna monitor this stuff? Impact on healthcare workforce. Are we gonna be out of jobs? And costs and accessibility. This is the bias thing. So this bias example became very famous. This was published in Science. And basically, this showed racial bias within an algorithm to manage the health of populations. So there was this algorithm that had been instituted to manage the health of a population. And the algorithm tried to pick out patients that would cost the most, patients that had the most healthcare expenditures in the system. And then they would be rewarded with an early intervention, more resources essentially, to try to reduce their healthcare burden. So essentially the idea was these patients are probably sicker, they have more health needs, and so we should give these patients more early intervention to help reduce the needs. As it turns out, if you use these models, Black patients were disproportionately receiving much less early intervention. The reason was Black patients were already costing the system less because they tended to be offered fewer resources in the system anyway. And so this model basically just reinforced that bias and ended up offering Black patients fewer resources again. And that's all it did. It just perpetuated the bias that was already in the system. This is an example of accepting AI that sucks. So this was a widely implemented proprietary sepsis prediction model that was incorporated into Epic. So basically, it would go into the medical record and it would predict whether or not your patient was going to have sepsis, and it would send out an alert. So what these folks did was they actually checked and said, okay, what percentage of the patients that got this alert actually had sepsis? One thing that was found was that the algorithm missed 67% of patients with sepsis. The other thing it found was that it led to alert fatigue, because for every 8 patients that it gave an alert on, and it gave an alert for like 40% of the patients, for every 8 patients, only 1 patient actually had sepsis. So it was a total piece of crap, but it had been incorporated widely and used, and if clinicians relied on this, patients would be harmed. So this just reminds us again that effective human-machine collaboration really is essential for clinical implementation. I do want to show this last thing, which is the potential for AI to amplify biases, which relates to inequitable access to technology. So it turns out, who are the patients that are offered access to the patient portal, which allows them to talk to their doctor directly? Well, it tends to be the wealthier patients. It tends to be the patients who are more highly educated. Females get offered it more than males, and whites get it offered in the United States more than Black or Hispanic patients. But as it turns out, if you look at once patients actually have access to the system, Black and Hispanic patients are actually more likely to actually interact with the system and download information. So it's not that a certain group of patients isn't going to use the system. So there's already a disproportion in terms of who's being offered access to the system. And so as we rely more on AI, this is just going to widen potentially that kind of technology gap, and now technology is going to become a social determinant of health. So in summary, AI does have the power to vastly improve prognostication, prediction, and make medicine much more efficient, but it's really not perfect yet. We are at a stage that requires humans to interact with AI with a critical eye to prevent AI errors from reaching the patient. And ultimately, AI cannot replace clinicians, but it'll certainly make those who use it properly much more efficient and effective. And so thank you so much for listening. I'm sorry, I didn't realize that this was like a dinner entertainment talk, so I prepared it like a real academic talk, but hopefully you have fun the rest of the night. Thanks a lot.